Hello everyone, welcome back to today's session. Today we are tackling sickle cell disease. We are going to think of the bloodstream as a massive highway system and the SCD crisis as a severe body-wide traffic jam. As its heart, SCD is a problem with the body's delivery vehicles, the red blood cells. These are like smooth, biconcave, fully inflated tanker trucks or rubber rafts. Their shape is plump and flexible, allowing them to easily squeeze and deform to flow smoothly through the narrowest back roads and the tiny capillary exits. They carry the vital cargo, that's oxygen. When these cells are deprived of oxygen due to stress, dehydration, or illness, the HBS, the abnormal one, inside these cells polymerizes and they stick together and crystallize. This is like those flexible rubber rafts suddenly freeze into rigid, sharp-edged crescent-shaped structures. They lose their deformability. They also become sticky, causing them to bump into and adhere to the blood vessels. The vehicle is now fundamentally damaged, leading to two major types of crisis. The rigid, sticky sickle cells don't flow well and don't last long, leading to two major forms. So, the gridlock. The rigid, sticky, crescent-shaped cells get lodged and build up, especially in the smaller capillaries. This is a complete instantaneous gridlock. So, the frozen crescent trucks block the flow of all traffic, cutting off the oxygen to the tissues downstream. The downstream tissues starve, causing ischemia, sending out massive distress signal perceived as severe pain, the classic pain crisis. This can happen anywhere, but often in the bones, chest, or abdomen. The normal red cells live up to 120 days. Sickle cells are so fragile that they constantly are destroyed, mainly by the spleen. So this is the second issue, the scrapyard overflow. And these only last for 10 to 20 days. These fragile cells are the wrecked trucks that constantly break down on the highway. The body's cleanup crew, the spleen, works overtime to remove the debris, leading to the rapid deconstruction or hemolysis. The constant excessive breakdown overwhelms the system, causing chronic anemia as the byproduct of cell destruction. The bilirubin builds up, causing jaundice. So here we have acute emergency crisis too. So acute chest syndrome. So the traffic jam, that is the VOC, hits the main pulmonary highway, often triggered by infection. It's life-threatening pile up in the lungs, causes chest pain and breathing difficulty. And then we have splenic sequestration. It happens in children. The spleen is the body's filter. In children, a massive number of sickle cells can get stuck and trapped in the spleen. This is a sudden extreme log jam in the main sorting facility, trapping blood and leading to sudden severe anemia and shock. Management focuses on the acute crisis relief and long-term prevention. So for the acute crisis management, we do IV hydration. We must immediately dilute the traffic to help flow. And then we give analgesia, aggressively manage the pain caused by the gridlock. And we give extra oxygen supply to the deprived areas. For the long-term prevention, we do hydroxyurea. That's hydroxyurea. This is the game-changer medication. It doesn't fix the mutation, but it tells the body to produce fetal hemoglobin. Hydroxyurea is the fleet manager who orders the production of brand new super flexible non-sickling rubber rafts. That's HBF. By increasing the ratio of HBF, the overall mix of vehicles is much less to jam, significantly reducing the frequency of VOCs. And so that's it. That's basically everything on the sickle cell disease, the traffic jam, and the gridlock. That's it for the episode.